what is a transition matrix? So we need to state what is the state transition matrix. We need to define in a very good way the role of transition matrices. Look out that the name is very important and you shall not confuse it with other things. This implies this. We are together up now. True? Look at the role. So this is a matrix. This is a matrix. It's going to be a matrix. Okay? Also because this is n-dimensional, this is n-dimensional, this one has to be mapping from n dimensions to n dimensions. This object here has a name and a symbol that I do not use to do not overload you with a notation, but you might find it. It's called transition matrix. It's the matrix that makes x0 transition in xt for any t. So this is not actually a matrix, but it's a matrix of functions. Okay? Extremely big difference. People watch out. This one is one of the critical points where misconceptions might arise. Okay? So let's go slowly here and let's be sure that we understand this is very often misinterpreted. This one takes a state and gives you the direction. Let's make domain codomain. Whenever I take A, what is the domain? Might be my position and velocity. True? And gives me x1 dot, x2 dot, and this one might map into this one, this point here. It means that this vector here, I take it and I put it here, and I get kind of where the trajectory starts. Are we together on A? The effect of A. A maps my state into the derivative of the state. How do I use the derivative of the state for making the trajectories? I put it back, taking this one and placing it on top of my initial condition. Are we together? This one is completely different. A goes from a domain that is position velocity into a velocity acceleration. EAT starts from position velocity and ends in position velocity. EAT tau, if I take this point here and EA tau tells me this point here is not a tendency. This is where I'm going to be. If I have, look at it. If I have EA1 equals to 2, 1, 3, 4, I don't know, something, and starting from this, applying this, I end up here, it means that if this was x of 10, this is going to be x of 11. See the point? Let's do another drawing. I know it might be confusing people. So EAT for t that goes 0 to whatever it is. We might have EA0. This one, what do you think is going to be equal to? Guess. Not 1, the matrix version of 1. And indeed, x of t is equal to EAT, x0. X of 0 is going to be this, true? That means that this one has to be the identity. Are we together? Do you see it? Why it has to be? Let's see also through the matrix exponential. This one is defined as identity plus AT plus A squared T squared divided by 2 factorial plus etc. True? If I take 0 here, I put 0 here, I put 0 here. True? All this stuff goes to 0. True? Together? Together? Perfect. If I put epsilon, that is a very small epsilon, what do I get? This one is going to be very small. True? Because this T is very small. And this is extremely small. True? What do I get? I get something that looks like this one. True? Now, x0. I start here. Let's pretend that my system is a spring mass system. It does something like this. Is it a spring mass system position velocity? Is it a spring mass system with damping or without damping? With damping. Let's say that this is x of 0.3 seconds. How does EA of 0.3 seconds have to be? This one has to be a matrix such that starting from this point, it maps this point into this point. Do you see it? Moreover, the same matrix, if this is x of 1 and this is x of 1.3, the same matrix has to map this one into this one. Do you see it? People, do you see it? 1, 2, 3. Perfect. If I take another initial condition here and I see that my system is going to do something like this, and this is x of 2 and this is x of 2.3. This matrix here has to map this one into this one. True? So let's generalize. I have all the potential x zeros. I define a specific t. It means that I define all the potential x of t, true, starting from this initial condition. If this is all the potential x zeros, in a certain sense, so EA03, whatever it is, has to take all the points here and map them accordingly here. True? I was having it here. Damn me. This goes like this. This goes like this. Okay? Now, very important thing, people, it's unlocking this. I hope you unlock this. This one is a matrix, true? How many columns will it have for this case? 2 columns, true? And the 2 columns are going to take this one into somewhere. Let's pretend that for t equals to 10, this one is equal to A1. Let me do it in this way, sorry. A1 A2, okay? This is A1 of 10, A2 of 10. Are we together? Somehow, this matrix here, EA10, is equal in this case to the column, to the matrix 2, 1, 1 minus 1. Are we together? It means that if I start from my initial condition x0, x10 is going to be equal to what? You compute it. So, what would you say, people? What would you say? How would I compute it? This one is this plus this, true? And then it means that I need to take minus twice this one, so 1, 2, plus twice this one, 1, 2. It should be around here. This is going to be x of 10. Are we together? And if I was starting here, accordingly. And if I was starting here, accordingly. Together? And if I was knowing that a of 5 was, for example, this and this, do you see that knowing a of 5 would enable me compute for every point where I would go? So the components are two. For every specific t, I have a specific a, a specific t, and this one for every point tells me where I go in that t seconds, milliseconds, hours, years, whatever it is. Okay, first component. Second component is that those objects here, they change with time. Now we will see some animations also. I think in one of the I think you see the animations, you kind of code the animations in one of the assignments. You will see the animations. But in a certain sense, you kind of have the intuition that this is a matrix, but the columns change in time. And for every specific time, you get something that looks like something, and that specific something will tell you every initial point where it goes. And watch out, because if this is, let's pretend that we are measuring in seconds. Okay, let's pretend we are measuring in seconds. If this is EA 5 seconds, it means that if this one gets mapped here, I throw it randomly, okay, I do not know where it goes mapped. Let's pretend that given this goes here. If this is x of 10,000, this is going to be x of 10,000, 0.5. Are we together? Because the time component, every initial condition, it's this as the interpretation of where I take my initial conditions in t seconds, minutes, whatever it is. Okay. 3 minutes, discussion per table. What you did not understand, what seems most strange, so that then we take questions. Go. What did you get? Try to explain to each other. Okay, people. Are there questions? Are there questions? There must be some questions. Listen to me. So questions, questions. Listen, listen, listen. Okay.
I can understand how we start from, like how we can start from x0, but like how can we kind of, let's say that you started from 10 and then went to 11 or something. So then how would you kind of manipulate the expression to show that it's the same as going from
This one.
Yeah.
So for now, we didn't see what is inside here, and we are focusing on the concept. Later on, we will see that the exponentials will reappear and the t's will reappear. These, so let's pretend, let's do it this way. Let's pretend that this is x of 10 and this is x of 11. How does this one have to look like? Draw a matrix that is compatible with this trajectory. Go. There's infinite ones. There's infinite ones. Try to find this one. You need to find an EAT that is actually what's out. It's not an EAT. It's an EA1. True? Together? Together it's an EA1 that has to take this one into this one. Go. Okay, people. Did you find it? Did you find something? Did you find something? No? Look at me. Look at my reasoning. Okay? So, we need to find this. True? We need to find a matrix that brings this to this. Now, just to make it simpler, I cut this one half and I cut this one in a half. True? because it's a little bit smaller. We've got 1 and 1. It's kind of easier to work with. True. Then I know that this one has to be minus a1 plus a2. Are we together? How much are we together now, people? 1, 2, 3. Perfect. I need that those two need to become this one. True? Now, if I take a1 that is this one and a2 that is this one, I get it. True? Sorry, this has to be. Sorry, I made a mistake. This is minus a1, so I need to have this one. This has to be a1, and this has to be minus a1. How are we together, people? 1, 2, 3.
Where does the minus a1 and plus?
Because if I start with this x, it means that this x in these coordinates has coordinates minus 1 plus 1. True? And if I do a, or better, what was it? I don't remember anymore. Was it 1, 10, 5? I don't remember. 1 times plus 1 minus 1, I need to end up here. True? It means that I will have a1, a2. Sorry, I think it was like this. Together? You see? Depending on t, this one is going to change. Up to now, we didn't see. We will see very soon. The point that I'm trying to make is that this animal and this animal, they do not, they are related, but they are very different animals. One gives you the direction, one gives you the actual point. Very much together, not at all, kind of. Are there other questions, people?
You said that we can go from 0 to 1, or from 100 to 101. It's not like t, it shouldn't be delta t.
Yeah. Where was it? I don't remember anymore.
Just also in the, also in the.
So if I put, let's rewrite this one. If I write it in this way, I think you are going to be happy. T plus tau equals to e a tau x of t. That is going to be. I think you will appreciate. I hope that somebody will feel like wanting to buy me a beer after this. It's also going to be equal to e a tau plus t x of 0. And this is going to also be e a tau times e a t x of 0. And that one is the condition that we wanted, that defines the matrix exponentials. True? Okay? You see, that is the time invariance. That is the time invariance. Okay? This one, it should be very easy, but let's just go there and do it. So it's still 3. Somebody made me feel like everybody's 3 here. Okay, it's me probably that I kind of